Why? So series circuits. We're gonna do series circuits in this one. Let me go over Ohm's law real quick. Ohm's law relates current, which is I, potential difference, which is change in V, also called voltage, and resistance, divide by R, resistance. Okay, now it really depends on what type of circuit we're working with. You know what type of circuit this is. You know what type of circuit this is. Look at that. It is a series circuit, no branches, nothing like that. To get the resistance for a series circuit, I would have to use this equation right here. Equivalent resistance for a series circuit. R total is the R1 plus R2 dot dot dot. However many resistances you have, or resistors you have to add them up. So for this one, let's go ahead and find the equivalent resistance. So equivalent resistance is going to be R1 plus R2 dot 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 dot. Let's go ahead and just move this thing right along. 2 plus 3, so what do we get? 5 ohms, okay? The resistance unit is ohms, 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 ohms. Okay, total voltage was given right here, bam, 10 volts, 10 volts right there, okay? Actually, no, can't do that. Can't do that for these. Yeah, because look here at my equations. Voltage for series circuits, total is 1 plus 2. So let's see if we can work this out a different way. Okay, so Ohm's law is I equals V over R. Oh no, we're missing current as well, aren't we? So our battery does get to be the total voltage. But the cool thing about this is that this voltage is kind of like the speed of the current running through. Every time it hits a resistor, that speed's going to reduce, but all of these will add up to 10. So we'll see that in a minute, okay? All right, so our total current, here's our current equation. Current is I equals voltage over resistance total. Okay, this is our resistance total. Okay, we're doing the total current, which divide the total voltage by the total resistance. So let's see what we get here. Our total voltage is 10 volts, and our resistance total was 5 ohms. So we get that. 10 divided by 5 is what? 2 amps. Okay, that's what an ammeter measures. Amps measures current. Okay, now that we have our totals of everything, total voltage, total current, total resistance, we can use that to actually find the current and voltage at R1. Current should be easy because look here. The current for series is going to be equal for all resistors. Okay, so easy, easy, easy. So if it's 2 amps as a total, that means the same current is going to run through resistor 1 and resistor 2. Remember that. It's the same current the entire time. Okay, now let's do the voltage though. Okay, so we're going to work with resistor 1. The voltage at 1 is what? So we're going to find that out. Okay, Ohm's law is I equals voltage over resistance. How do I solve for the V? Get rid of the R by multiplying. Bam. So R times I equals voltage. Okay, let's plug in our resistance at 1. So that's going to be 2 ohms. And our current is going to be the same all the time. So 2 amps, right? So we end up with 4 volts at resistor 1. 4 volts, so 4 volts. Easy, easy, easy. Okay, current at voltage 2, current and voltage at R2, so we say it's 2 amps. Let's do the voltage there. So voltage 2, resistance 2. Notice how I'm using subscripts. How do I get rid of the R2? Times R2, right? R2D2. Okay, R times I equals V2. All right, what do we got here? So our resistance at resistor 2 is 3. 3 ohms times our current, which is 2. And that gets us 6 volts. And what was our total voltage? These add up together and get you what? 10 volts. And what was the value of our battery? Haha! Got it. Cool, right? All right. Good job. Good luck. You're going to need it.